Hi guys. Hi. I miss you. Hello guys.
Hi, Miss Nisma.
Hi guys. I miss you so much.
Me too.
I promised you that I'm going to be opening the camera at the end, the last session, right?
Miss Reveal.
Yeah. Hi Noor, Marwan.
Miss Lag.
Miss, I'm using
Yeah.
my brother's account, so that's my problem.
Okay. Is this better?
Yeah.
Okay. Hi Malik.
Hi, Miss.
Okay, who else is here? Anyone is here? Please open your camera so that we can see everyone before we
Miss
start.
Nisma.
Yeah.
It's like you were telling us I'm going to face reveal in the last session. It's like that, exactly.
I'm going to do what?
Face reveal.
Exactly. So here's the face reveal.
Yes.
Okay.
Whose name is Ahmed Tariq here in the session?
Who's Ahmed Tariq?
I don't know. My best.
This is
Maybe
this is
his.
me.
He is.
I think he's Yusuf's father.
My name is
So,
Yusuf.
Yes, yes.
yeah, this is Yusuf. So since most of us are here, Omar, I want you to open the camera. Salma, let's take a screenshot of this glorious moment.
Okay, wait,
Yes, I'm going to screenshot it as well right now.
Okay, I'm going to screenshot it.
I did not screenshot it.
Yeah. So everyone, please. Yes, Noor. Hi, Noor. Malak, you can open the camera if you
By
want.
the way, Miss Nisma, I took a screenshot.
I'm going
You
to
did?
screenshot it
I'm
right
using
now.
like the laptop that I can, so I can screenshot.
Yeah, okay.
Does anyone here have a MacBook?
It's only you, Mr. Munsif.
No, it's like you just hit F4 and then you click on there's an app called Screenshot.
Okay, so I'm going to count 1, 2, 3. Smile, everyone. Okay. Okay. 1. Oh, Saif is yawning. Okay. 1, 2.
I took a screen snip.
Okay, great. So we are going to start in like 1 minute from now, and this is our final session. And surprisingly, I am really sad.
ليه؟
Miss, could I say something?
Yeah, because I'm not going to see you till next year, inshallah.
ليه يعني يا مس؟ مش انتي قلتي بتدرسي E5؟
ما هو till next year, till the next
3 months, yeah,
أقل.
3 months of not seeing someone. Is that very happy?
يا أدهم افهم أنا افتكرت مش هتشوفنا السنة اللي جاية أساسا.
Okay, there
No.
is Adham
So
Tamer.
this is year 5, so she's
Adham
probably
literally sent the picture on
see.
the group.
Oh, I love it. This is nice.
So you
Just
see,
send it
You
right
can
now.
send it. I don't know how you can send it to me by email. You have my mail, right? You have my
I
mail.
don't have your email.
You don't have my email?
No, I don't have.
Yeah, can you write
only
it?
I have it.
Okay,
I
I'm
don't.
going to post it.
I have it.
I'm going to post
I
it,
have it.
and you can send it to me, and I will upload it. Okay, guys, since
Miss your slow motion.
I am.
Like you sometimes you like.
You said you're going to post.
So Adham Tamer is here, and Marwan Amr joined us. So let's take another picture, okay?
Okay.
1, 2, 3. Okay. So now I need you to turn off your videos, unfortunately, because we're going to start. Yeah, so let's do this.
What is that you want?
And mute your mics, please, guys, so that I can, because I'm hearing a lot of noise.
No.
Okay, guys. So the final revision is today. I'm going to revise all of the parts included in your exam. So there are 4 parts. Please mute your mics. Thank you. Okay, so 4 parts. Part 1 is the electricity. Part 2, rocks and minerals. 3 is heat, and 4 is magnetism. Okay, Ibrahim, you can turn off your video now and mute your mics, guys. Okay, so the first part is the electricity, and I'm going to say all of the highlights and like summarize the whole thing as much as possible. This revision is very important, guys. I'm going to highlight some stuff that might come in your exam, so please pay attention. And when I upload it to the Google Classroom, I want you to rewatch the video because it is really important, okay? So
which video?
the video that we're doing right now, because I'm going to upload it to the Google Classroom. Okay?
Okay.
All right.
Okay.
So the first thing is that please turn off your videos, guys, and mute your mics. Okay. So the first thing is that matter is made of smaller objects called the atoms, and inside the atoms there are 2 kinds of particles, the positive particles and the negative particles. You don't have to know the names of all of the particles, just know that the matter has smaller objects inside them that are called atoms, and inside them there are Marwan Amr. Yeah. You do this every time.
It's not me, I swear.
Okay, I believe you. Adam, would you please turn off your video?
Okay.
All right. So inside the matter, there are small objects called atoms. Inside the atoms, there are even smaller particles that are charged. Some are positive and some are negative. The negative ones are much smaller, and that's what makes them move easily than the positive one. So this is why the negative particles inside the atoms are responsible for the electricity, because they are the ones that can move more easily than the positive particles. The positive and negative particles inside the atom are just like magnets. So if you approach 2 similarly charged particles, like 2 positive charge, they will repel. But if you approach positive charge to negative charge, they will attract. So the question is, why is the atom itself, the whole atom, is neutral? What is the meaning of neutral? Neutral means that it does not have a charge. It's not positive or negative, so it's not charged. Monsef, I will be doing a part, the whole part, and at the end of each part, I will give you the opportunity to ask questions. We just don't want to waste time because we are very short in time. Okay, dear? All right? All right.
Yes.
All right. So the atom is neutral. This means that it's not positive or negative. And why does the atom neutral, although there are positively charged and negatively charged particles inside them? It's because the positive particles number is equal to the negative particles number. So it's like each positive particle is attracted to one negative particle. So they are pairs, and this makes the whole atom inchargeable. It's not charged, it's neutral, because each positive particle is attached to one negative particle. Okay, so if the number of positive particles inside the atom is equal to the number of negative particles inside the atom, the whole atom will be neutral. It will not be charged. Okay, so next is the word build up of charges. It means that we're talking about static electricity. So once you read the word build up, know that we're talking about the static electricity. examples of static electricity is balloon rubbing or of course the lightning. And you can get back to the resource pack to know the exact mechanism of how rubbing a balloon will cause static electricity, or how lightning is caused by static electricity. But what really matters to me is just to know the examples of static electricity. Okay, now if we said instead of build up, we said flow of electricity, like they are running in a tube or something, then we are talking about the electric current. So the difference between static electricity and electric current is that static electricity is the build up of charges, while the flow of electricity is the electric current. Okay, in order to flow, the electricity to flow, it has to have a pathway or like a road to flow through. This road in the world of electricity is the electric circuit. And the circuit is made of three main parts: a power source. I think someone is, yeah. All right. So the power source, which is the battery or the cell, the load, which is the buzzer, the lamp, or the motor, all of those are loads, or the connectors, which is the wires that connects all the parts together. So we're going to remind ourselves with the symbols. So we have the circuit, the cell, sorry, and the cell is the long line and the short line facing each other, parallel to each other. The long line represents the positive charge, while the short line represents the negative charge in the battery. Okay, the circuit, the lamp or the bulb is the circle with the X inside it. The wire is just the straight line. This is the buzzer, of course. It looks like the cup, and the motor is the circle with the M inside it. I put those two symbols in a separate slide so that you won't get confused between them. The open switch is the one that the two ends of the switch are not meeting, they are away from each other. So this means that the switch is open or the switch is off. It's like turning off the light. This what happens: the switch is open, the switch is off. It means that the circuit is open, the electricity is not flowing through it. While if you meet the two ends together, this means that the switch is closed. It means that the switch is on and the circuit is closed. So there is electricity flowing through the circuit. Okay? Next is the difference between the series circuit and the parallel circuit. So the series circuit, when all of the parts of the circuit are in the same pathway. This means that if one of the bulbs got broken or I removed it, the other will turn off, or this means that I opened the circuit, the electricity will not reach the other bulb. While in the case of parallel circuit, which we have in all of our home appliances and the house electricity is connected in a parallel circuit. This is because the parts of the circuit are not in the same pathway. So this means if this one, for example, got broken or I removed it, the other will still be working perfectly. Okay, now let's talk about how to get the bulbs brighter or dimmer. If you added more power source, which means more batteries, or you made the wire shorter so the electricity won't get into a long trip, or you use thicker wires, so this means that there is a lot of wires inside a lot of smaller wires inside the big wire, so that the electricity can flow even more. This means that the bulb will light brighter. But if you, for example, were working with only one battery and there are far more bulbs added to this circuit, or if you use a longer wire so that the electricity will have to go through a long trip, and very thin wire so that the electricity will not be able to flow easily in it. In this case, the bulb will light dimmer. Okay. Now, what about the conductors and insulators? All metals are conductors. All metals like what? Like iron, like copper, like aluminum.
Miss, I have a question.
Okay, I will give you the opportunity after finishing, ya Monsuf, okay?
Okay.
Okay, so all the metals, whether they are iron, copper, aluminum, all of those are conductors. And we will add to them one non-metal, which is the graphite. The graphite is the tip of your pencil. This also is a conductor, although it's not a metal, okay? So all metals plus the graphite are conductors, while all non-metals minus the graphite, so this means that plastic, wood, rubber, all of those things are insulators, okay? The last part of this part is the safety rules. So how you want to get electrocuted, you don't play with the electrical socket, of course. Don't touch the electricity while your hands are wet. Don't poke your fingers or anything inside the electric socket or the toasters. Don't touch the bare wires if the wire is not covered. Don't touch it. Never use the electricity near water. Never take electrical devices or appliances into the bathroom. And of course, do not overload plugs. So this is it for the first part, guys. If you have a question, please raise your hand. Yes, Monsef.
I just wanted to ask like 2 questions.
Yes.
First one, are the like lessons in the covered material the only lessons we have in the exam? The 4
Yes.
lessons?
Yes.
Second question, are like the insulators and conductors of heat the same as the insulators and conductors of electricity?
Of heat, yes.
Yes.
Except the graphite.
Yes.
Okay.
So like the conductors of heat are the conductors of electricity.
Yes.
And the same thing with the insulators.
Yes.
Okay.
Okay. Yes, Khadija. Yes, Khadija. Please, guys, make it quick because we are very short in time. Yes, Khadija.
In the series and parallel circuits, what if the series like for example, like the brighter and dimmer, like when there
In
is more
in the series circuit only.
Like when it has like more bulbs in the series circuit, more than the battery. So like
It will light dimmer.
To light dimmer. So like when there is a series circuit, it's like the dimmer.
Yes. Okay.
And the parallel is brighter.
The parallel will stay the same. It will not be affected. When we talk about brighter and dimmer, we're only talking about the series circuit. All right? Okay. Yes, Adham. Adham Tamer. Yes, dear.
Miss, I want you to I want to ask on only one question.
Yes.
Can you repeat the insulator? I mean the electricity, the atoms.
The atoms. So the matter in matter is made of smaller particles called the atoms. Okay. Inside the atoms, there are 2 types of particles: negatively charged particles or positively charged particles. Okay. The negatively charged are much smaller, so this is why they move easily than the positively charged. So they are responsible for the electricity. The atom, the whole atom is neutral. It means that it's not positive or negative, because the number of positive particles equal the number of negative particles. You just have to know this information, piece of information. That's it for the atoms. Is there any other questions?
No.
Okay. Omar, yes, Omar.
Miss, I have a question.
Yes.
When today I'm gonna study with my mother,
Hmm.
I'm gonna study from the PowerPoint or from the book.
Well, I prefer that you go through the book and especially the questions in the book, and you can watch the video, or you can watch the video first. It will make it easier for you to go through the questions and the book itself. Okay?
Okay.
All right. Yes, Marwan. Marwan Muhammad.
Miss, the heat conductors and insulators, their name is thermal conductors and thermal insulators, right?
Yes, we are coming to the heat. I'm asking about the electricity. Do you have any questions related to electricity?
No.
Okay. Yes, Monsif.
I just had another question.
Huh.
In this picture, are the purple things real or is this Photoshop?
Yes, it is real.
What is this?
It's a type of rocks. You don't have
No, I
to
mean
know
the
it now.
purple thing.
I think it's quartz, but I'm not quite sure. I'm going to find out and tell you, okay? Now,
Okay.
let's move. Okay, let's move, guys, with please because we're really short on time now. Adham Tamer, do you still have a question?
No.
Okay. Now, let's move with the next part. Part 2 is the rocks and minerals. And in the rocks and minerals, I want you to remember the definition of the minerals. Remember that there are two ends in the minerals: natural and non-living things that makes up a rock. So the minerals have two ends: natural and non-living things that make up a rock. Okay? There are several properties that can make us, or it makes it easier for us to classify the minerals. Four properties. Number one is the hardness, and we can measure it using the Mohs scale. And number two is the color, and you know that some rocks or some minerals are similar in colors and many are different in colors. Number three is the streak, and the streak is the powder left when I rub a rock against a rough tile, whether it's white or black rough tile, the left powder behind is the streak. And then there is the luster, and the luster is how this rock bounces.
I didn't hear you.
You didn't hear what?
I didn't hear you when you said streak.
Streak is the powder left when you rub a rock against a rough tile, whether this tile is black or white. When you rub this rock against the tile, the powder left behind is the streak. Then there is the luster, and the luster is how the rock bounces the light off. So it could be a metallic luster, it could be pearly, it could be glassy, or it could not be bouncing any light. In this case, we call it a dull rock. The types of rocks, of course, we know that there is the igneous rock, and the igneous rock is made of the magma cooling down. If it cools down quickly, it will make small grains like the basalt, but if it cools down slowly, it will make large grains, which forms the granite. The second type is the sedimentary, and this is where we find fossils because it's made of several layers. One of those layers are dead animals and plants. Examples are the sandstone and limestone. The metamorphic is made by the sedimentary and igneous rocks when they are subjected to very high heat and pressure. Okay? Now, next is the rock cycle, of course. We have the igneous rock, which is made by the cooling of the magma. And then after weathering, when they are breaking down and they are subjected to erosion, it starts to form sediments. And then the sediments start to be compressed into sedimentary rocks. And then the sedimentary rocks will be pressurized or subjected to high heat, sedimentary or igneous, both of them, to form the metamorphic rocks. Okay? The uses of the rocks is very easy. We have four examples: the slate, the granite, the marble, and the chalk. The slate is impermeable. It does not pass the water through it. It's very hard and can be cut into sheets, and that's why it makes it perfect for roofing tiles and billiard tables. The granite is used to make steps and roads and buildings because it does not wear away easily. The marble is made for floor tiles, wall tiles, and statues because it has attractive texture and color. The chalk is made of skeleton of tiny sea creatures and it wears away easily, and that's why we make it for the sticks using in writing on blackboards. Now let's move to the soil. The word soil means the mix of rocks, dead plants, animals, air and water and minerals. All of those mixture makes up the soil. And it makes up three types of soil. The first one is the sand, and the sand is the one that has high permeability, which can pass the water easily through it because it has large particles and large air gaps. The silt is always medium in everything. It's permeable, it has medium particles and medium air gaps. The clay is tiny in everything. It is tiny particle, has tiny particles, it has tiny airbags, and this makes it have low permeability. Okay, I'm done with this part. Do you have a question, guys?
Yeah, Miss.
Who's this?
I'm Adham.
Yes, Adham.
Adham Tem. Can you repeat part 2?
The whole part?
Yeah, because I couldn't understand it.
You couldn't understand what, dear?
Part 2.
Okay, can you rewatch it when I put the video? If you have any question after rewatching it, you can post it and I will answer it happily. Okay? Because we have 10 minutes for each part. We still have 2 parts to go. Okay? If we have time at the end, I can repeat it for you. All right? Okay, thank you. Next is the heat part, guys. And the heat, first we're going to talk about the difference between the word thermal energy and the word heat. The thermal energy is the energy that occurs due to the moving particles of matter. It's like when you rub your hands against each other, you will feel the heat in between your hands. This is exactly what happens in all of the particles of matter that produces heat. The particles start to rub against each other due to their moving, and this is what produces thermal energy. The heat, the word heat, it means the flow of thermal energy in one object, from one object to another. So when I touch something hot and this energy starts to move from this hot object to my hand, this is what we call the heat. The heat is the flow of thermal energy from one object to another. There are several heat sources, but the main one and the major one is, of course, the sun. And there are others like the fire and the light bulbs. All of those are heat sources. The heat transfer, please pay attention to this word. The heat transfer always from the hotter object to the colder object, because lots of you made it wrong in a previous homework. I think I'm lagging. Am I lagging? Yeah. Okay, is this?
Yes, you're lagging. Yes, you're lagging. Yeah, you're lagging.
Okay, this is better?
A little bit.
Okay.
Yeah.
All right. So the heat always transfer from a hotter object to the colder one. Okay. Now, what about the temperature? The temperature is the measure of heat. It tells us how hot or cold an object is. It is measured by, of course, the thermometer, and there is a liquid inside the thermometer. It could be an alcohol or mercury, and we use those two because they are very susceptible, or they are really sensitive to heat changes. They expand and they contract according to the pressure, the temperature around them. So they expand in high temperatures. The temperatures could be measured by 2 measuring units, whether it's degrees Celsius, and this is very common in the Middle East, or Fahrenheit, and they use it in America. Now the freezing point of water is 0 degrees Celsius. The water boiling point is 100 degrees Celsius, and the normal body temperature is 37 degrees Celsius. We have heat conductors and heat insulators, and this was Marwan's and Monsif questions. Are they the same as the electric conductors and the insulators? Yes, all metals are heat conductors, and all non-metals are heat insulators. So all metals like iron, copper, or aluminum, and all non-metals like plastic, wood, or wool. Does anyone has a question, guys?
No.
All right, let's move.
Me, miss.
Yes, Monsif.
No,
I just wanted to ask a little question.
Please, if it's not important, make it at the end, because we have less than 10 minutes, okay? All
Miss, I
right.
have an important
Who has an important question? Yes, Omar.
Miss, before you said that zinc and oh, they are non-magnetic, so
Who's
you said before that
Guys,
and
there are 9 minutes left.
Miss, you said before that zinc and gold and metal and aluminum
non-magnetic. Non-magnetic.
are heat.
They are what?
Non-magnetic.
They are, as long as they are metals, they are heat conductors.
Miss, you're lagging.
You hear me, guys?
You're lagging a lot. Miss, you're
Miss,
lagging.
you're lagging. You're lagging.
Okay, do you hear me now?
Yes.
Yeah.
Yeah.
Yes.
Again, so all metals are heat conductors, but not all of them are magnetic. Am I clear?
Yes.
All right.
Yes.
Now let's move.
Yes.
All right. Let's move with the magnetism, guys. So the magnetism. Please mute your mics because there is a lot of noise in my ear. Thank you. Okay. There are several types of magnet shapes or types of magnets. We have, of course, the famous bar magnet, the horseshoe magnet, the wand, the disc, the ring, the rod. All of those things are found in your books, and I already uploaded them in a previous video that you can get to them again. Magnets are made of 4 main metals: iron, cobalt, nickel, and steel. Any other metal than those 4 is non-magnetic, okay? Only 4 metals are magnetic: iron, cobalt, nickel, and steel. And by the way, steel is a type of iron, so you can put them with iron, and we say that the iron, cobalt, and nickel are the only magnets found naturally on Earth, okay? Magnets have 2 poles, north and south. Similar poles, of course, repel. Different poles always attract. There is something called the magnetic field, which is the area of magnetic force around the magnet. Okay, so when you get out of this magnetic field, the magnet does not have a power over the thing that it's going to attract. So the magnetic field has a specific area around the magnet that has its own power over it. It's very strong. The magnetic field is very strong on the poles of the magnet. It's very strong there, and very weak in the middle of the magnet. Now, what is the electromagnet? If you don't have a natural magnet, the one that got created as a magnet, you can actually make one. How? They found out that all the electricity, any electricity or electric current, it has also an electric field that starts to produce around it. So this is the thing that we're going to use in order to make a magnet, an electromagnet. How? It says electric current passing through a wire coiled around a soft metal core. What does this mean? A soft metal core is the iron nail, and a wire coiled is the copper wire that we coil around the nail. And then we are going to connect this wire to an electric current. So we're going to connect it to a battery.
Looks like a battery.
Yes, so you connected it to a battery, and this way the electric current will start to flow through the wire. The nail that the wire is coiled around will start to act as a magnet. Okay?
Does it have to be battery D?
If you can connect it to a socket, of course it will work, but this way you will get electrocuted.
I mean battery.
Yes,
You said in the make an electromagnet battery D. Does it have to be battery اللي هي التخينة دي؟
No, I didn't say so. Maybe you heard me wrong. A battery, just a
I
battery. Any
No.
battery.
I mean in the assignment you said battery D or the video يعني.
No, any battery, dear.
Okay.
Okay. طيب. Now the uses of electromagnets, we used it in recycling of stuff. We can separate things that are magnetic from things that are non-magnetic while we are recycling using an electromagnet, or in the vehicle scrappage, which is places where lots of iron pieces and cars are thrown, and we need to move this from one place to another, so we use a large electromagnet to do so. There is something called the magnetic keeper. A magnetic keeper is a bar of iron that fits into the magnet in order to keep the magnetic field or the magnetic power flowing through the magnet and the magnetic keeper. This way it will make it strong. But if you just throw a magnet in a drawer or in a place where it's open, it can lose its magnetic power very easily. So this is why we stick the magnetic keeper to it in order to keep it flowing and preserve the magnetic force in it. There are magnetic materials that we talked about, which are the iron, cobalt, nickel, and steel. And there are non-magnetic materials like the copper, gold, aluminum, silver. All of those are metals, but they are not magnetic. They are non-magnetic. And of course, anything that is non-metal is non-magnetic too. Okay. Now, how to safe handle the magnets? Of course, you don't bang them together. You have to wear safety goggles, because if one of the magnets broke, they won't get into your eyes. Don't drop the magnets. All of those things will make the magnet weak. If you want to stick two magnets together, slowly allow them next to each other. Wear protective gloves, because some magnets are, when they get into the body system, it could hurt you. Don't put it next food or drinking water. Don't place it in a high temperature or a place that is wet, because all of these things will make it weak. Don't put it next to a video tape or an audio tape. It's going to erase everything on it. Don't put it on next to credit cards. The same will happen. Mobile phones, interactive whiteboards or computers, TV screens, all of this will affect the color of the screens and all of those things. I am done, guys. Do you have a question? We have like 1 minute, 30 seconds for all of your questions. Yes, Adham.
Miss, I have a magnet, but I don't have a keeper. What do I do?
Well, sticking a magnetic material to it is always helps it to keep it preserved.
Miss, but I put it like north, south, and beside it south, north. Is that okay?
Yes, but the other two, the other two ends is also it could lose the force from it. So you have to stick a lot of magnets next to each other. Unfortunately, a keeper is very well, because it just gets stick to the whole thing and preserve the force. Okay. Yes, Ibrahim.
Okay. Miss, someone must be talking.
What? Ibrahim.
Someone is drumming on the laptop.
Okay, Ibrahim, do you have a question, Ibrahim? Okay, guys, we are
Yes, Miss, I have a question.
Make it quick.
I have a question, Miss.
I just want to tell you something. If it went down, I'm going to upload the video, and I will upload a link where you can ask all of your questions, and I'm more than happy to answer it. Okay?
Okay.
Okay. Yes, Ibrahim.
Miss, I had a magnet and I put it beside a credit card.